Right, so I'm making this video kind of as a prerequisite study on the material that I'm actually going to produce next week, which is going to be basically troubleshooting the SX4's ignition system. So it seems to me good idea to have some idea what the system theory of operation is actually all about before you actually watch a video on somebody troubleshooting it, right? So instead of actually getting the schematic out and doing my usual routine where I go through the schematic, what I did is actually basically take the schematic, strip it down to its essence, simplified form, if you will, to get the main points of interest across, and hopefully you can correlate this information with the follow-up video, which is going to be on the troubleshooting. What does the system basically consist of, right? The ignition switch itself, as you might well imagine. The engine control module actually controls all the functions with respect to the ignition triggering, the inputs and triggering. We've got the Coil On Plug ignition assembly itself here, boxed in the green dashes. Here's what the unit actually physically looks like, right? So you can see it is in fact a 3-wire system. What do those wires actually consist of? We've got a 12-volt supply. We've got a hard ground on the emitter that's on the igniter, which is housed internally inside the assembly, of course, the primary and secondary coils. And on the base of the transistor itself is actually the trigger line. We'll get to that momentarily. In addition to that, we have multiple inputs that actually go into the ECU, and of course the spark plug itself, right? So all well and good, that's the components, but how does it actually function? At the ignition switch, if you were to go to the crank or run position, we'll actually take the 12-volt feed, apply it to the primary within the coil assembly, and it does nothing actually at that particular point in time because the igniter transistor is actually not conducting. So nothing's actually happening at that particular instance, at that particular moment in time. But as the engine actually rotates, if you're in the run or the crank position, hopefully the engines are rotating, obviously. So the inputs would actually start to come alive. We have the crank sensor, we have the cam position sensor, and there's multiple other inputs, engine coolant temp sensor, knock sensor, even the wheel speed sensor, believe it or not. All that information is actually fed in either in a digital format, in the case of the cam position sensor, or an analog format, just a variable reluctance sensor. For the crank, and the cam is actually a Hall effect sensor. So that information, whether it be analog or digital, is actually fed into the engine control module, a module within the engine control unit. It looks at the particular mode of operation of the engine. It applies the corrected timing as opposed to base timing trigger out to the base within the igniter itself. So you can see here on the drawing, I've actually shown that the trigger signal is 0 to 5-volt signal. So with this igniter in this particular configuration, as you can see here, if you're familiar with transistors at all, this is an NPN type transistor. Even if that means nothing to you, suffice it to say that on the base, on the trigger line here, what we need is a high input. We need the 5-volt signal in order to meet the criteria in order for the igniter to actually conduct, right? So we have a fixed ground on the emitter, so we're good there. We need a negative. We need a positive, as I said, the high side of the pulse, and we need a more positive, which actually we also meet that criteria from the feed coming from the ignition switch itself. So once the pulse actually comes high from the ECU, the base actually turns the transistor on into the conducting mode, if you will, right? Turns the switch on, a solid state switch actually on, at which point in time, we get the magnetic field present itself. When the conductor is actually conducting, a magnetic field, field of flux, encompass, if you will, the primary and secondary, but it doesn't fire the plug at that particular instance. Once the trigger line actually goes low again, and the igniter within the igniter transistor within the C.O.P plug assembly actually stops conducting, then we actually have a field collapse. And at that instant, that there's a high tension or high voltage induced into the secondary through mutual inductance of the primary and secondary coils, and it actually fires the plug. Okay, so I'm going to leave it at that. I hope that actually all makes sense. So just before everybody's brain starts doing one of these, I'll just leave it at that. Okay, that's it. See you next week. Cheers.